This is kind of a follow-up to my ghost video. This is, again, back to a customer's question. He had ghosting problems, and he didn't understand the use of launch cables. So I already covered the ghosting, so if you haven't had a chance, watch that video. Now we're going to talk about launch cables, and I was looking for videos on the description and use of a launch cable, and we have several videos, but they never really go into depth on why you should use a launch cable. I thought maybe we would talk about why we use them and then show their use there, and you'll see why it's required to be used when you test an OTDR. There's also an unseen advantage by using a launch cable. It almost sounds used car salesman-ish, like your OTDR is cheaper when you buy a launch cable. No, it's not, but it is eventually on the savings that'll happen. So we'll give you the other advantage here in a minute. So launch cables, and okay, so we can say launch and receive cables. These are cables that we are putting in front and in the end of any cable that we're testing with an OTDR. You can see this is a common one. They look like, we call them little hockey puck ones. So why do we use them? When we don't test with a launch cable or a receive, at that matter, we can never really test the first connector on your OTDR. So connectors, we know, look like spikes, okay? So what are they really showing us as a spike? They're actually dropping and spiking. So the drop is the attenuation, the spike is the amount of reflections or optical return loss, back reflections that we're getting. And that is an important number, especially in single mode fiber. A lot of us ignore those numbers we see, or we ignore how high the spike is. And it's an important number. High back reflections can be a big issue in our single mode, especially single mode systems for sure. When you're certification testing, sometimes the only thing that's in that cable is the first and last connector. If you just plug that test connect cable into your OTDR, you can't provide the first and last connector results. I've had several people tell me they've had to retest because they didn't use launch and receive cables, and yeah, I've seen that happen. And the only answer is, yeah, I have to redo all of my work. So why do we do this? We talked about that spike that we get. Now that spike isn't a straight up and a straight down. It's up and it has width to it. So the width is what we will refer to as the dead zone. Connectors have really large back reflections. All right, that's going to affect the detector in my OTDR. The detector is very sensitive to low levels of light. Now we're turning that light up by huge factors, and it's basically blinding the detector. Now, like your eyes, the only thing that takes away blinding is time, right? Recovery time. So we can't stop the test. So what's happening is we're getting a high reflection from the connector, the OTDR is getting blinded, and for a moment in time, the OTDR stops functioning. So that's what we call the dead zone. So the width of that spike, we want really thin spikes, but we're never going to have a straight up and down. We're always going to have loss of a testable distance. When we test a connector with an OTDR, we're really just taking power levels. We're taking power levels before the connector, this event, and after. And this is for all events. And the difference between the pre and post power is the attenuation of that event. Well, if we don't have a cable in the front of that event, we can't, for that first connector, we can't get the pre-power, the power before the first connector, because there's nothing before the first connector. So that's why we load up the front of that test with a length of fiber. And it's just a dummy load, really. It really has nothing to do with our test. It's just giving us the ability to test just before that first connection, which technically is making it the third connection because we're plugging our test cable into our launch cable. So whenever we test connectors with an OTDR, we're testing the mated pair. I remember years ago, certification-wise, it was about 0.75 dB was the pass-fail. Now today it's most commonly 0.5. Most OTDRs come loaded with 0.5 for reflective event losses. So this same statement is true for the other end. How do we test the end connector? Well, we can get the pre-power, so before the connector, but that last connector is it. There's nothing after it, so we can't get another level. So again, we can't test the first or last connection. So what we do is we put another cable on the end. We could call it a receive cable. And that now makes that last connector the third to last. So we're testing the pair between the end of the cable and the receive cable. So that's why we need these, because you're excluding those connectors, and sometimes those are the only things we're testing on a cable. Right, we could have fusion splices and bends and stuff in there, but you know, I would say the most important thing that we test in this cable would be the first and last connector, and we need to include those. So I'm going to show you a scan without launch cable. So I have a box of fiber here about 3.5 kilometers, and I think it's got an event in there. It's got the first and last. So we're going to plug that in, and I'll show you how, well, the OTDR won't report on the attenuation values. And then I'm going to add launch cables. You can see a launch and receive cable on the ends where we sandwich that test cable in the middle, and that will allow us to test the connectors, the first and last connector. So we're going to swing around here, and I'm going to hook everything up, and we'll do a test. All right, now that we're set up at the OTDR, you can see I have a trace running on my box that's about 3.2 kilometers long. It does have a reflective event in here. I've got it on real time to show you. So we talk about these spikes and how they have widths. Now, one of the questions, well, how long should my pulse cable be? You can see here I have a short patch cord plugging into my box. The problem is that this cable is 2 meters long, so the dead zone, the lost time distance that we get here, is longer than this 2 meter cable. So you would expect to see a spike here for this first connector and the spike 2 meters. Because the dead zone is longer or greater than the distance of that patch cord, you see these two events as a singular event. So, you know, the question is always, well, what length do I get in my pulse box? Now, I always recommend a 100-meter pulse box, or, sorry, I'm using that as a other term, launch cable. Pulse box is also used. So I always get asked how long. So what I like to do is I do 100 meters for my launch cable for multi-mode. I always try to use a longer one for single mode. Now, the launch cables that we use look, this is a nice short one, and I think we can get like 150 meters or so. And again, this is a little hockey puck style. You can have either connector style you'd like, and the fiber's underneath here, and we just have the leads that we can access. Now, for me, for single mode, could you use a 100-meter launch cable? Sure. I always err on the side of longer is better. So for single mode, I use usually 500 is what I recommend. So it might be in a larger case than this. Now, why do I do that? A couple of reasons. Your dead zones, the area of distance you lose after every connector, grows depending on the pulse that you use. So the longer the cable, the longer we pulse the light. The longer the pulse, the longer the dead zones. And I'm showing you this here in real time because, look, I'm going to turn that pulse way up. Look at your dead zones. Oof, that's a little more than we need. It's a lot more than we need. You can see how much wider these are becoming. So the longer the cable, the longer the dead zones. So we always want a pulse box or a launch cable longer than our biggest dead zone. I always go 500 meters. Look, single mode fiber is about 8 cents a meter. So every 100 meters is going to add $8, roughly. Okay, so a couple extra 100 meters might cost you $24 more. I would prefer to have more to cover any long cables that I'm testing. So having them at 500 meters will cover all the short ones for sure, but then if we ever come across a longer cable with longer dead zones, we're covered. The other reason is connectors wear out. So the connectors on these pulse boxes, launch cables will wear out. They'll have to be repaired. Connectors will wear out in your OTDR. So there's the other hidden advantage of using a launch cable is if I'm testing a lot of fiber and I don't use a launch cable, I'm plugging into my OTDR, could be hundreds of times that day, and that's going to shorten the life of that connection here. Now, if I'm plugging into the launch cable instead of the box, so I only plug in once into my OTDR, and I plug hundreds of times into the launch cable, yes, you'll wear that connector out, but you're talking a $20 repair compared to a $600 to $1,000 repair if we have to replace the connector in the OTDR. So that was that used car salesman thing where you can't afford not to have a launch cable, right? It saves wear and tear. All right, so our launch cable has to be longer, in my opinion, than the biggest dead zone that we have. And again, I'm going to use 100-meter ones here because I've got a 3-kilometer box here, so it's not a big deal. So I'm going to go back and I'm going to actually do a time test here. And this is going to show you the problem of not being able to test the first and last connection. So I've got my test cable plugged directly into the OTDR. And you can see Here's my first connection. Here's that event right here, about, I don't know, 2.2 kilometers down, and then there's the end of my cable. Now you'll notice it's a short spike, and I'm getting a nice clean drop. Why is that? Remember the previous video with the terminating connector, so no ghosting. All right, so we're getting a report, and we can see here there's actually a fusion splice here in this box that we couldn't see with our eyeball, but at about 1,000 meters, there's a fusion splice that's at about 0.08 dB, I believe that says. And then here's our connections here inside, and there's the end of the cable. Now what you'll notice is I don't have. This is my first, see my 0 position? I don't have information there, no attenuation, because I can't wrap this event. I can't get my prior power value to get attenuation. You'll notice here on the end, same thing, my attenuation values are non-existent for the end connection. So we're skipping, we're eliminating that in the test, and these are two of the most important things we need to test. So what I'm going to do now is, and again, you don't see the patch cord because the dead zone or the lost distance we lose from that first connector. So what I'm going to do here is I'm going to unplug my patch cable, and I'm going to put a launch cable on each side of my test fiber. Again, this is the reason we want to use these. So here's my first one, and as always, what are we going to do? Clean, clean, clean. So I'm going to clean, and I'm going to, this OTDR happens to have an APC port, so I have a launch cable with an SC APC here. And then I'm going to mate this into my test cable. So here we go here. So now we have 100 meters in front of my test cable. And now here's the end of my test cable with my terminator. I'm going to take that off, and I'm going to put a receive cable on the other side. So I have another hockey puck, as you will, and I'm going to clean that and mate those together. So now I have 100 meters plus or minus on each end of my test. So I'm sandwiching in my test. Now I'm going to put this on the end because we know about ghosting, and I don't know if this trace will have a ghost or not, but I guarantee if I put this terminating connector on the end of the test, I guarantee I'm not going to get a ghost. So let's retest this cable. Now we'll show it in real time here. What do we see here? You can see there's your 100 meter first launch cable, and there's your 100 meters second. So now we can get measurements on the front and back side of our first and last connector. So if I do a standard test here, timed, get about 10 seconds per wavelength, pretty decent for a shorter cable like this. What you'll see is it will now incorporate this second and third connector, right? So that's where my test cable meets my launch cable, and it will give us this here because it's now not the end cable, it's the end of the test cable, and then the first part, the first connection on the receive cable. And what do we see here? 113 meters. So that launch cable was a little longer than 100. So there's my first connector pair, 0.16. And you can see it's passing, right? Negative 51 reflections, pretty good for a UPC. And you can see here, 100 meters before the last, we get our result for that connector that used to be the last. We get the pair. It's the last connector on the test and the first on the receive. So this would be how we would test if we're doing certification testing. Now we can include the first and last connections. Something else you can do, a lot of your OTDRs will have this. I believe if I go over to a settings here, what we can do is we can tell it that it has a launch and a receive cable and give you the distance. So I could put 113 and 113, I think is what we're in those two here. So it's kilometers, so it'd be 0.113 for each one. You can change this to meters or feet. And what it'll do is when we do the test and the reporting, it will exclude that launch and receive fiber. And so for the customer, that's going to be an invisible cable because it's really not part of the cable that we're testing. But you can see why we want to use launch cables so that we can include everything in that cable that test cable, all the events to be tested for our certification. So hopefully this helped, and again, this was a direct result of a technical call that I got, and I just wanted to kind of do a hands-on and show you what a cable looks like with launch and receive cables and the reason for doing that. So grateful for any questions that you have, and hopefully this will help you when you're testing with your OTDR. Thank you.
Check out our channel and hit the subscribe button for new videos.